Any questions on that? So here's the beauty of this. I can zoom in. If I zoom in, how can this circle right here represent any circle? How can it represent any circle of any size? So I'm picking the circle of radius 1. How is it that we can think of this circle so based on what we're talking about here, how can this circle then represent any circle? How can we see it as being any circle?
Because any circle is going to have one radius. It's going to be some amount of a radius.
All right, so if my circle is 60 meters, if the radius of my circle is 60 meters, how can we still think of that right there as 1? Even though my circle is 60 meters, or has a 60 meter radius, how can I still think of that as 1? One radius length. Do you see? One radius length. How can it be a circle of 0.02 inches? So now my radius is 0.02 inches. How can I still think of that as a circle of radius 1? It's still 0.02 is still one radius length. Okay? So this is the way we think of the unit circle. We think of it as every circle, and these numbers 0.5, 1, what do they represent then? 0.5. What does that really represent? What's that? Half of whatever the radius is. You see? How about 1/10? 1/10 of whatever the radius is. 0.8. 80% of whatever the radius is. Do you see? So that's why we put so much emphasis on the unit circle, is because we can think of it representing any circle of any radius. That number 1 or those numbers 0.5, they represent how much of the radius, right? So 1 is like 100% of the radius. 0.5, half of the radius. Okay. Let's see here. Where do I want to go from here? So let's see. What am I write these down here? 2.5, 0.3. Here, can I copy and paste? Let's see. Will it work? Spinning wheel. All my life, the spinning wheel. Oh, it worked. Just need it bigger. There we go. Okay, so now, represent these angles on the circle. So I don't have a handout of nice circles for you, so you just got to make your best circles that you can. Represent these angle measures on the circle. Oh, actually, sorry. Let me show you where all the integers are. Now, that'll be easier. There we go. So I'm marking off radius lengths. So represent these angles on a circle. 2.5, 0.3 radius, 4.25, 6.1, -1, and -5. Okay?
So those dashes are whatever the numbers should go.
No. What are the dashes? 1, 2, 3, 4, 5, 6. The dashes are 1, 2, 3, 4, 5, 6 radians. I'm just going to lag you a little bit. So keep working on them, and you can check as you go. There's 2.5. That was for your quiz too, right? That was the last one on your quiz. That's 2.5 radians. There's 0.3. That's 0.3 right there. But you need to see the other ones. That's the closest I can get to 4.25. So that's 4.25. So, and we're thinking about it as that arc length, that outside, or that openness of the rays. So where would -1 be? Yeah, you go clockwise, so it would be in line with this one here. So -1 would be this right here. Does it make sense? So that would be -1 radian. -5. 1, 2, this would be -3 here. -4. So -5 would be directly above this. Does that make sense? Yeah. Directly above, right there. So -5 would be this right here. Yeah. Okay, questions on radians?
So when you're representing the negative, you put the, I guess it makes sense.
You start again at the 0 point, and then each radian goes that way.
Yeah, now they go this way, so it would be like,
Represented by the circle in the middle of the arc length, right? That's how you kind of know it. 'Cause when you do it the other way, you do the circle on the other side, the little angle.
yeah, so you really can't tell if it's negative or positive here.
Oh.
It's just that. Yeah, so yeah, going clockwise is negative and counterclockwise is positive. Okay, and we said, so do these end up on nice places on the circle or not so nice? Yeah, they're just in kind of just random, not random, but they're just in not places relative to symmetry on the circle. So we want symmetry. So we said that exactly halfway around is how many radius lengths? 3.14 or pi. It's exactly halfway around. So all the way around?
6.2.
Approximately 6.28 or exactly 2 pi. Okay? So what about 1/4 of the circle? Half a pi. What about 3/4 of the circle? It'd be 1.5 pi. 1.5 of these, or 3 pi over 2. Okay? And so using pi then, we can get nice symmetric places on the circle. Exactly 1/4, exactly 3/4. What about exactly 1/8 of the circle? 5/4. Okay? What about exactly halfway here in what we call the second quadrant. So if this is pi over 2, this is a half of pi, and this is a whole of pi, then be 3/4, right? Okay. Close to 4 pi, but a little bit less would be 5 pi over 4, 1 1/4 pi. And this is halfway between 1.5 and 2 would be 1.75 or 7 pi over 4. Okay, let's find the value in your calculator. Or I'll do it right here. But the value of 5 pi over 4. What would you guess it to be? That number. It's a number. What would you guess it to be? About. This is 3, and this is 4. 3.8 or 3.9. So let's do it. What'd you get? 3.92. Okay? Approximately. So when we start dealing with the expressions that have pi in them, don't lose sight of the fact that it all goes back to 1, 2, 3, 4, 5, 6 radius lengths. It's just shy of 4 radius lengths, so it's 3.92 radius lengths or 3.92 radians about. That's what 5 pi over 4 is. Okay, just like pi was about a little bit more, about 15% more than 3. And that's halfway around the circle. Okay, so we said that this is all about percent of the circle. So pi, what's the corresponding percent of the circle? 50%. Top of the circle, corresponding percent?
25%.
25%. That's a 25% angle right there. Okay? Down at the bottom, 75%. Full circle. Okay, so here's the key. If we're going to relate this to percent, really all we need to know is what is 100% in radians. What is 100% in radians? 2 pi. That's the key. If you know that 2 pi is 100% in radians, then you can find any percent for any radian. And likewise, for any radian, you can find the percent. So what percent of the circle is 5 pi over 4? Well, that's actually... okay, so what number of radians is 53%? Find the number of radians that's 53% of a rotation of a circle. Go, find that. So how many radians is that? What would you do? You want 53% of what? 2 pi. So you take 0.53 times 2 pi, and what do we get? What is it? 3.33? Someone say it loud. Okay, we'll just do decibel. This is good. Do I have it correct? About 3.3p? Does it make sense?
Yes.
Yeah, because it's about a third of the way from our 3 radius lengths to 4 radius lengths.
So 53% is also another way of saying rate.
What's that?
When you say 53%, you're saying also kind of like...
No, that's not radians. That's percent of the circle. That's 2 different ways of measuring angle. Percent of the circle or radius lengths. They're totally different. 53% of the circle corresponds to 3.33 radians. They're 2 different things, but they're the same angle. Does that make sense? Okay, so find what percent of the circle is pi over 7. So where's that be about here? So if the radians is pi over 7, find out what percent of the circle that is. So we're talking about conversions of angles here. What percent of the circle is pi over 7?
You said what percent?
Mm-hmm.
Is it 0.0?
How'd you find it? What'd you do?
I divided pi over 7
Uh-huh.
by 2 pi.
That's it. You're going to find the percentage, you take the part over the whole, and what'd you get? 0.07? 7.4?
7.14%.
0.714, which is 7.14%. Okay, so whenever you need to do conversions, a nice kind of center point is to convert to percent of the circle. So for instance, now let's talk about degrees. So this is our radians, 1, 2, 3, 4. I'll do degrees in blue. Or sorry, radians. So 1 radian is based on 1 radius length on the circle, and it's what percent of the circle? Find what percent of the circle it is. 1 radian. What percent of the circle is that?
15.9%.
15.9%. Everyone able to get that? How do you get percent? You need how many radians over the total number of radians for a full rotation, which is 1 over 2 pi. So it's all, to get percentage from radians or radians per percentage, it's all based on the fact that 2 pi radians is our full circle. 2 pi is, this is the key, 2 pi is 100% of the circle. So if 1 radian is 15.9% of the circle, what is 1 degree? What is 1 degree? What's that? Find what 1 degree is, the meaning of 1 degree. What is 1 degree? Okay? It's 1/360th of a rotation, which is, tell me the percent.
2.77%.
No, it's not. It's got to be less than 1%. Right? 1 over 100 would be 1%, so this is going to be less than 1% of the circle. What is it?
3.27.
So that's 0.28%. Do I have that right? You got to move the decimal place, right? So you take 1 over 360, multiply by 100 to get percent. So the angle of 1 degree, this is how we define it. It's the angle whose rays cut off 1/360th of the circle. You see? 1 degree is the angle whose rays cut off 1/360th of the circle, or about 0.28% of the circle. Okay, so find how many degrees is, we'll say 68% of the circle. So how many degrees is 68% of the circle? Go. All you need to know to do that is, how many degrees are 100%? 360. So if you know that, and what did I say? Percent was 68? Somewhere in here? How many degrees is 68% of the circle? 244? And how many radians is that? Find out how many radians that is. Same angle. So 68% of the circle is 244 degrees. How many radians is it? What would you do? How'd you get that? You take 68% of 2 pi. So 0.68 of 2 pi gives you 4.27 radians. All these represent the same angle. Okay, all those represent the same angle. One is percent of the circle, one is in degrees, where 1 degree is the angle whose rays cut off 1/360th of the arc length of a full rotation, or 4.27 radians. All represent the same angle. Okay, questions? Yeah.
I'm not sure. How did you get to 240?
Where did the 244 degrees? I told you 68%, right? So 68% of what, if we wanted degrees? Yeah, 68% of 360. Other questions? Okay, so what I want you to do is use this kind of thinking, not some formula that you remember from the past. Use this kind of thinking to convert, I don't know, 5 pi over 3 radians to degrees. And 146 degrees to radians. Use this type of thinking. Would mean it's a two-step process, right? What would the process be to convert 5 pi over 3 radians to degrees if we're using this kind of thinking? What would we do first? Find the percent of the circle. And then from the percent of the circle, get your degrees. Okay? So this is a foolproof way that allows you to do it without ever having to memorize anything. Okay? If you just understand, what do you have to memorize? This is all you have to memorize. That one full circle is 2 pi radians. And one full circle is 360 degrees. That's all you have to know. And you have to understand how percent works. Then you can convert anything. No formulas to remember. Okay, so 5 pi over 3 radians to degrees. First we'll find the percent of the circle. That's the percent of the circle that 5 pi over 3 radians is. And then what will we do? We'll take that same percent of 360. So just take this percent of the circle, that's a percent of the circle right there, of 360. So you're just going to multiply that, and what do you get? 299.89. Right, you're going to take that same percent of 360 that the percent of the 2 pi was. Okay, 146 to radians. What do we do first? Change the percent of the circle. What percent of the circle is 146? As a fraction. That's the percent of the circle. That 146 degrees is. We're going to take that percent, just leave it as a fraction. You don't have to know the percent even. So we're going to take that percent of what? 2 pi. So we're taking, this is think of this as the percent of the circle that 146 degrees is. We're taking that same percent of 2 pi.
6.04
6.04 radians.
I am.
All right. Tell me what percent of the circle is this? 146 over 360. What percent is that? 90 something? No, that's not right.
No.
It's 2.5.
I got 2.5.
Never mind.
Or almost 41. It's gotta be.
So this 41%? So that 146 over 360, 41% of the circle. So 0.41, or that ratio times 2 pi is 2.55? Right about here. Right about there is our 146 degrees, 41% of the circle, and also 2.55 radians. All are valid ways to represent that angle.
So going from the 5 pi divided by 3,
So what percent of the circle is that?
it's 5 pi divided by 3 over 2 pi.
Make sure that pi gets in the denominator. Did you put parentheses around the 2 pi?
Yes.
What percent of the circle was this?
It's like 83.4%.
83.4%? Someone else get that? And so now we want 83.4% of 360,
Times 360.
which is just this fraction times 360. It's the same thing. Does it help?
Yeah.
Other questions? So converting angles, if you just know percents and know what 100% is for the given unit that you're using, you can convert any angle. Convert it to percent first, and then take that percent of whatever unit you want. Okay, so I'm going to erase the screen. Is it okay? So what I want you to do is, say for 1 radian here, estimate the x and y coordinate. Do you agree that that gives us a point, right? That gives us a point on the circle. Estimate the x and y coordinate for that point. So for 1 radian, estimate the x and y coordinate. X coordinate is approximately 0.55. Y coordinate is approximately 0.85. You see it? What are the units of those numbers? So 0.55 what? 0.55 what? Radius lengths, right? So that's 0.55 of a radius length. And same with this one. Just here the radius is horizontal and here the radius is up vertical. Okay? This x-coordinate, so the precise x-coordinate of that point is called the cosine of 1. It's the x-coordinate on the unit circle for an angle of 1 radian. Well, for any angles, but in this case, for one radian. And the y-coordinate, this is called the sine. Okay, so estimate the cosine of 3 and the sine of 3. Estimate. Don't use your calculator. Use the picture. Cosine of 3 is about what, and sine of 3 is about what? So cosine of 3 is about? Is it -1? It's a little bit less than -1, so let's call it what? Negative 0.99. Okay? What about sine of 3? Yeah, so it's about 0.1. So the x-coordinate's negative, it's almost -1 here. The y-coordinate's positive, it's about 0.1. So that's what the cosine of an angle is. It's the x-coordinate of the point for that angle on the unit circle. And sine is the y-coordinate. Anybody have a question? So next week I won't see you till Wednesday. So there'll be homework due for Wednesday. We'll be diving into sine and cosine next week. Right. I was wondering what that question was about.
Sorry.
Didn't make any sense.